Thank you. I would like to introduce myself. My name is Donaldi Permana. I'm a research scientist at the Meteorology, Climatology, and Geophysical Agency of Indonesia in BMKG. Uh, I'm currently working in the. I have a broad interest in the atmospheric, oceanic, as well as the cryospheric sciences. My latest work that I'm working on the climate change based on the tropical glaciers in the Indonesia. It's including in the glaciers. So I'm looking at how the climate can be preserved in the high mountains. And first of all, I want to say my greetings to all of the attendees of this the first World Virtual High Mountain Summit in Colombia, uh, which is the monitoring system of high mountain forests, paramos, and glaciers. So this is the honor from me. So I'm going to start my presentation. So um, the title is the climate change based on the tropical ice core of the oceania glaciers in the Puncak Jaya Mountains, Papua, Indonesia. And I'm gonna start with uh, the the natural mechanism that influence the climate. So we know that the changes in the solar output is one of the factor that can influence the climate. And also the second one are the changes of the volcanic aerosol in the atmospheres. This can cause the temperature of the Earth cooling down due to the aerosols in the atmosphere. And the third one is the internal variability of the coupled atmosphere ocean system, which is including the ENSO El Nino Southern Oscillation, the monsoon systems, and the North Atlantic oscillations on the decadal time scale. Human also influence the climate. The changes in the concentration of the atmospheric greenhouse gases is important because we know that the concentration of carbon dioxide has been increased since the industrial revolutions, and also the changes in aerosols and particles from the burning fossil fuels and biomass also influence the climate, and also the changes of the reflectivity of the Earth surface. This is due to the human activities when they change the Earth surface. Uh, this is the comparison of the carbon dioxide concentrations in Indonesia, in Bukit Kota Tabang, and the global and Mauna Loa in the USA. So we saw that all of this measurement has shown the increasing of greenhouse gases. Even we can see that Indonesia has slightly less CO2 concentration compared to the global concentration of CO2. And this is the sea surface temperatures in the Pacific Oceans, which shows the location of Puncak Jaya, Papua, which is one of the warmest sea surface temperatures. And on the eastern part of the Pacific Ocean is the South America. We see that some ice cores has been drilled in this region, like from the Huascarán and Quercaya, and in the back in the bottom figure we can see that the Puncak is the wettest area that has the high precipitation compared to around the world. So tropical glaciers can provide the important climate change information through the glaciers itself, the area itself, or from the ice cores that been recorded in the glacier. So unfortunately, these glaciers in the tropics are now is retreating. We can see that many studies has been done, in South America, in Africa, as well as in Papua, Indonesia. And we can go to the next slide. So this is the study area. So Puncak Jaya has at least 3 glaciers back in the 2009. It is the Karsten glaciers, East North Wolfern, and the West North Wolfern. So during during the last research, we also collecting some rain samples from this area, from the low elevations up to the high elevation at the 3,945 meters above sea level. And we do collection from the 2013, 2015, and basically just to see how the isotopic composition of this precipitation compared to the climate controls in this area. So one of the results that we show that on the interannual time scales, we show that the rainfall isotopic composition at all stations from the lowland up to the highland are generally more enriched during the El Nino years compared to the normal years. And this is important information when we do the interpretation of the ice core that we drilled from this area. So this is just to show you how the glaciers are retreating in this region. At the top figure, we see the land. Yeah, I think this is the satellite figures back in the 1989. We see the glaciers are still has a large area, but in 2009 it's getting smaller, and it shows that the glacier has been retreating in this region. And back in 2010, we drilled the ice cores in this region with depth about 32 meters depth, and which is on the west dome is D1 and D1B, and the east dome is D2. And from there, we can see that the ice cores can be powerful contributors to the proxy reconstruction. First, they can provide the multiple lines of climatic and environmental evidence. And the second one is ideal to revealing the rapid climate change. So ice cores can be, we can see the temperature, atmospheric chemistry, volcanic history, even the anthropogenic emissions from these glaciers. This is just some pictures how we process the ice core in the Bird Polar and Center at the Ohio State University Laboratorium. And in 2009, just last year, we published a paper, Disappearance of the Last Tropical Glaciers in the West Pacific Wampool, Papua, appears eminent. So basically, we show how the results of this, the analysis of the ice cores, as well as the retreating of the area of the glaciers. So we also put some stakes during the drilling project back in 2010, and this is just some pictures show you how we do the stake measurement. So the stake were put on the whole of the ice core drilling, and year by year we go back to these glaciers just to see how long the stake that has been exposed at the surface, just to show how the rate of the ice thinning in these glaciers. So this picture shows that from 2010 to 2015, we see that the ice thinning rate is about 1 meters per year, but in 2015 to 2016 is take about 5 meters, and this is basically due to the strong El Nino these years, and this also has been observed in the Quelcaya ice cap. This is the analysis, topic analysis from the ice cores with the 32 depth meters. So we can see the reproducibility of the isotopic ratios in the figure A and figure B. We also see more dust and chemicals at the top 4 meters, which shows that these glaciers uh, has been disturbed with the percolation, the water percolations due to the heavy rainfall in this region. So dating the Papua ice core was challenging. From the 32 meters depth, we see that there is a tritium peak at the 24-meter depth, and these peaks are associated with the 1964 horizons, where during this time, like the Soviet Union has been done the atomic bomb test, and I think this is also observed in other glaciers. Uh, and from that, we also do the matching isotopes of with the Nino 3 sea surface temperatures, because we know that from the previous studies that the more enriched isotopes are associated with the El Ninos. So from this, we can make the dating of these ice cores. So from this paper, we just show the dating up to the 1964, up to the 24 meters depth. But if we go back up to the 32 meters depth, it's associated with the 1920. And if we also compare the isotopic ratios with the global and regional temperatures, both parameters shows the increasing trend. We can see from the first top figures, which shows that the isotopes and the temperatures are show the similar trend, increasing trend. But if we do comparison with the precipitation at the bottom figures, it doesn't show the increasing trend. So this is to show that the isotopes are more reflecting the temperatures rather than the precipitation. And this is the satellite image of these glaciers from 2002 up to 2018. So we can see the retreating of the glacier area. Like back in the 1850, the glacier are still big, but now it's getting less and less area. I think in 2018, the area is just about a half kilometer square, and now getting smaller. And last one, I think this is my last slide. This is just to show the projection of these glaciers. So we use the Cordex Southeast Asia projection scenario for the RCP 4.5 and 8.5. And this is from, I think, 5 models. It shows that these glaciers will disappear at least 2026 at best, but likely it will be disappears in 1 or 2 years from now. And this is very unfortunate because this will be the first tropical glaciers to be disappeared, because it's located at the lowest elevation compared to the other two glaciers in the tropics. Okay, so I think that's all my presentation. So thank you for your attention, and you can access the link below there just to see how this research has been done. I also want to thank to BMKG as my institution for supporting this research, and also I would like to thank to the Bipolar Research Center at the Ohio State University that also has analyzed this ice core application for this research, and also to the Freeport Indonesia that has been logistically supported this research during the expeditions and during the during the stake measurement that we do periodically every year. Thank you.